Hello and welcome to all of my combo lords out there. I'm doing this stream today at what's 10 a.m. for me, because that's what fit in between my other things. Not sure what time it is for all of you, but I assume a different audience and time zone than some of the other people who catch my evening streams. So good to catch you all here. And one reason I'm doing a stream today, before I get into other filming activities I'll tell you about, is that yesterday, although I was unable to stream then, we passed a fun number of subscribers here on what I'm now calling the Domotro from Combo Class channel, since it did outgrow its bonus channel status. And on this channel, the number we passed might sound really arbitrary in our base. Let me write it down. The number that we passed that I'm calling interesting, that I'll have to explain. Listen to that, you're the straight up rooster. I wanted to mention that I heard a rooster crow, which I haven't heard in a long time. A neighbor having one of those. I find it kind of cool. I don't mind it. Unless it does it too early. But yeah, no, roosters. I was gonna swear that one was doing that in the background, and I thought you folks practically wouldn't believe me because it's never happened here before. But that's apparently a new neighborhood classroom rooster, which will fit along great with our other classroom chicken wherever that fella snuck off to, because we do actually sort of have a classroom rooster here as well. This fella is our classroom chicken, but like I've noted, we don't have a good enough habitat for a living one, so we have this ceramic one. Now it has a real friend. In any case, before I wipe this clean, actually, maybe I'll do a quick, slightly more detailed reminder about what was on this piece of paper, on this thing, before I get into why I'm about to talk about this particular number. First, before I erase this was the notes of a more detailed version of my last bonus video that I filmed with Carlo, my main camera guy. A longer version of what should or shouldn't be sent to my new rooster, to my new mailbox. It's like a P.O. box, but not technically called that, because P.O. boxes, it turned out, couldn't accept mail from as many carriers as just a private mailbox. So a mailbox that's not my address, that people can send broken in clocks and stuff to. I made a whole longer version of what should or shouldn't be sent to me. And then I wrote the address slightly wrong at the end. And when I was double checking it before I posted it, I was like, oh man, I gotta redo this and just post another one. So I made a much shorter version, because that ended up making sense in my brain then, of what should or shouldn't be sent to me. But to do a slightly more detailed version of that right now, because that bonus channel may not get released with the bonus video with the wrong address might not get released. Basically, I started a new mailbox with the intention of getting people's old clocks and or calculators, dice, or other classroom supplies that fit the recurring themes here to fill grade -2 with more than ever. Because this was the amount, plus whatever one's already broke, that I was able to get for really cheap or free from like yard sales or thrift stores or things like that for grade -1. But grade -2 is coming pretty soon, and now that we have a good amount of viewers here, maybe 1 out of 1,000 of you wants to send me a clock. And even if it was that many, it would be too many, because we have hit past this number, which is, as the title hints, 2 million. If we were to be writing numbers in base 6, it would look like the number we call 2 million. We'll get into that in a moment. First, for the quick version of this, I do want people to send me anything cool. That the bonus video is, just go on this channel under videos if you want to see the address. And you can send things that aren't clocks if you think they fit the vibe here, to be a cool background thing for grade -2. And the real quick ground rules, apart from the obvious ones that don't send anything illegal, dangerous, or super messy, those are just obvious rules that please keep. Also, don't send me anything you don't want me to show on live streams, because if I get cool stuff from people, I will dedicate some live streams to opening a few of them and showing you guys. The addresses and names on the outside, of course, will be removed first, but whatever's inside the box, I might show right on a live stream, and then everyone will see it. So nothing too personal in that regard, and also nothing that you care if it breaks, because I won't like purposefully break it right away, but over the course of the teaching it will help do. It may have a faster lifespan than it would sitting on a shelf collecting dust. So people can send, if you happen to have any old clocks, not the digital type that just has the numbers if you plug it in, but one that looks like a clock even if you don't plug it in. And if they're working, I might take the batteries out so they stop ticking, so they could be broken or not. Or if you got dice, whiteboards, an abacus, whiteboard markers, calculators, and all of those things are in the category of don't actually need to work, except the whiteboards and whiteboard markers. Those actually need to work. So that's a little thing that I'm going to erase right now. So I have this whiteboard ready to talk about this number. The other whiteboard I had sitting right here, I don't want to erase yet because it has a hint of the next episode that's coming out on the main channel tomorrow, on the Combo Class channel. And on that channel, make sure you've checked out the last few episodes, which are, they've gotten pretty long because some of the topics that I'm doing near the end of the grade took me 20 minutes or 25 minutes to make sure I had done the episode and included everything I wanted to. And this turned out to be another one. It's about bases again. So we can see real quick spoiler alert of there's some, it's not really a spoiler because it's me describing what's going on there. But there's a whole field of different base interpretations of numbers or representations that we're going to look at. So it is about numbers and different bases again, like today's special is part of why I timed it for this, in addition to us passing that cool number. But it's not going to be like going into one or two really obscure bases of some type, like some of my other episodes on that Combo Class channel. Some of them are like, let's look at imaginary bases, or let's look at fractional bases or something. This is more just the typical integer bases, but looking at a whole field of a bunch of them in a row to see the patterns when you're looking at a whole grid of numbers and representations in different bases. And it turns out when I was playing around with that stuff, I found a lot of things that now seem obvious and simple to me, but probably haven't occurred to a lot of you. And so I kind of realized, at first I was almost second guessing making an episode about all these things, because I was like, these are a lot of cool connections I found, but they're pretty obvious feeling now. But then I realized I'd never considered them a few years ago. And so I realized a lot of people probably have never considered them. Maybe I can then show you the obviousness of some connections, and maybe they're important because looking at different ways that you could write numbers could be useful. And the simplest variation would be, well, maybe we would have a different integer for our base. And if so, instead of just investigating one of those, we're going to look at a whole field. And for example, if I'm wondering, we can take a line out of the field is what part of this episode's going to be about. And this won't spoil much, so people can think about this on their own if they want. If I say, what are all the ways I can represent the number 3 in a typical integer base 2 or higher? Well, 3 is 1, 1 in binary. It's then in base 3, it's 1, 0. And then it's a 3 symbol in base 4, 3 symbol after, 3 symbol after, 3 symbol after, 3 symbol after. So technically there's an infinite amount of representations there. We could go up to any size of integer base. However, they're all 3s after one point. They're all a single digit symbol that represents 3. And these two are sort of different than a single digit symbol. And so it kind of has 3 different or distinct representations among the typical integer bases? What can we learn about the number 3 of a thing based on that set? What can we learn about other numbers based on their set of distinct or different representations in integer bases 2 or higher? So, turns out that I stumbled into a lot of classic concepts that we've already talked about, that you already probably would know even if we hadn't. Some of the most classic concepts from numbers re-show up here under other possible definitions, new definitions that I stumbled into just by playing around with numbers that are defining things you already know, but in terms of this set of its finite representations and what happens in there. Now, I'm going to go through the comments real quick. And that episode, by the way, is coming out tomorrow sometime on the main combo class channel, so stay tuned for that. And before I talk about why I picked today's stream, apart from the fact, well, this lines up with that, what that all, weird base interpretations, has to do with this number and has to do with the 2 million I put in the title. But first, let me take a little peek at the comments. Thank you all for joining me here, and to whoever wants to send me a new lab coat, if you do, send it in the next couple days maybe, because I'm going to buy a new lab coat before long, and it has to be a legit lab coat. You could send a lab coat costume for fun, but the one that's going to be my main one is going to be like the type of lab coats that cost 40 or 50 bucks because they're actually super durable. This thing has been subjected to so much. I'm surprised it's in mostly one piece. This is when there was fire in my pocket. It like barely changed the color of it. And so this thing's durable. Thorns, fire, hard to get through it. And so I'm going to get a new one for grade -2. And the episode that's coming out tomorrow on the main channel is sort of the third last episode of the grade. But technically the fourth last, because it's the third last main one, and then there's going to be a sort of more documentary-like finale of my transition of grades and some flashbacks and behind the scenes of this grade that you folks may not know, such as how last year, while building this show from the dirt, I had to get 2 major hip surgeries, and it was an intense pain before and during that. And other rarities. We'll also take a fun field trip in the finale. And I might even camp out in the classroom for a night. I might bring a tent out here for a night for the finale. And we will have a destruction ritual of some of the clocks that have gotten moldy and stuff. And yes, I am also secretly collecting certain things like clocks that I'm not going to show you guys yet, because they will splash onto the scene when grade -2 hits, which will either be on April Fool's Day or shortly after. Now, in any case, thank you all for joining me. And what we're going to look at next here, and people mentioning the sun maybe, I don't know if you're talking about here or other chatting, but we do get bad glare here as well. Also, I'm using a different webcam right now, an older one I had that has pros and cons. It's HD compared to the normal computer screen camera that I sometimes was using, but this one is not perfect yet. This one is, I left it out in the rain slightly once and it got kind of damaged, and now I feel like when it's dark, I don't know if this is just the camera or something I've done to it, but when it's dark, it feels like it makes everything really red. I don't know. It's hard to tell. How many negative grades will there is one question I'll do before I continue. And who knows? I would like to make many. All I know is, you can't plan too far ahead. You can have goals. My goal is to make many, but there's not a fixed number. And I will be guaranteed making strange creative projects my whole life, Likely, many of them will continue to be called negative grades of combo class, but we'll have to see. Grade negative 2 will be very similar to grade negative 1 with some slight upgrades in my schedule and video quality and stuff. And as far as why there's only 4 more episodes exactly, that relates to this whole concept too. If I had extended that chart further, I would have seen that the number 36 of a thing is sort of special because it's written as 100 in base 6. And if you want to think about what does it mean to be a number that looks like 100 in some base, that is one of the patterns out of many we'll go into in tomorrow's episode on the main channel. And in this case of being a 100, the number 36, that is how we write it in our base, but that amount of a thing regardless, if we were in the base I recommend for humans, would look like the number 100. It would be the first 3-digit number. And so that's a good amount of episodes for me to put into the show, because having 100 episodes by our basis standard would be even more ridiculous. That would be too much for a single grade probably. They're kind of like a season of a TV show's worth or like a year's worth on the main channel. But here, if we go to base 6, the base I recommend, it looks way better. And so that's the amount of episodes we're going to go with. And we so far have had the amount that what I'm putting out tomorrow is the 4th last of those. With the 100th, not the number 100, but the 100 look-alike amount of a thing, if we were in base 6, as the amount of episodes. So, if we were in base 6, then my finale would be called 100. Also, if we were in base 6, right when I passed this amount of subscribers, we would be at this amount, it would look like. However, I realized a slightly paradoxical thing when I was making this title. I said, if we were in base 6, then I would have just passed this amount of subscribers. But if we counted in base 6, more people would appreciate my videos, and I already would have had more subscribers than that. So if we were in base 6, I probably would have been at the 3 million in that base, actually, because more people would understand the cool stuff in my videos. In any case, if we were in base 6 but nothing else changed, the amount of subscribers, 93312, when I passed that, would have looked like what we call 2 million. Now, when we break down the prime factorization of this, which is more fundamental than either of these base representations, that's how it happens to look in base 10, that's how it happens to look in a slightly better base. More fundamental is its prime factorization. Now, I'll write the prime factorization in base 10, but we could have drawn dots or something to be it. It's base independent. So the prime factorization of this thing is pretty neat. 2 to the 7th power times 3 to the 6th power. Now, that makes it really close to a 6th power itself. If that was 2 to the 6th, meaning if there was 1 less 2 in the prime factorization, meaning if it was half as big, then it would be 6 to the 6th. 2 times 3 each to the 6th. And it's true that half of this over 2 equals, it's like 46656, I think. Let me double check that. Is that the right number? What is 6 to the 6th power? Did I get that right? It is, yep, 46656. So this one is 6 to the 6th power, the number that would look like 1 million in base 6. And okay, we got bad glare here. Let's try and work on that. We're just going to switch angles. So, maybe this will be better. Now, here, let me see if there's anything I need to reply to right here, by the way, in our comments. All right, and someone said, who is Combo Class Bonus 2 that I mentioned earlier? Now, they have multiple channels on here, but I'm not sure if I should, like, direct people to them because it's a little kid, so I'll wait to see if they comment and make attention to it. But in many of my past streams, there have been appearances from people under different names, and I kind of lost track of what the channel kept changing to, although they have a limit on how often you can change channels. But I think this kid got a hold of his mom's channel and his dad's channel, and has at some points changed each of their names to things like Domotro 2 and Combo Class 2. Combo Class Bonus 2. So, in any case, right here, we got slightly better light right here, and even though this webcam, I can't tell if it's worse enough in how it treats lighting and stuff that it's not worth its quality difference. So, over here, this number is super special, 6 to the 6th power. That's really neat looking. And this is twice that. So this is 2 times 6 to the 6, we could write it as, because of that prime factorization. Now, with this right here, there's a lot of fun ways we could write that, because 6 is such a good number that we can write 6 so many ways. We could say that this is like twice 3 factorial to the power of 3 factorial, or I could have replaced any of those 3 factorials with a 1 plus 2 plus 3, or a 1 times 2 times 3, or just the product of the primes 2 and 3. Now, the 2's and 3's in here, along with whatever 1's you want to be able to combine, along with the fact that 1 plus 2 plus 3 equals 6, give you so many ways you could rewrite this. So, if anyone wants, leave their fun other ways of writing 93312 in a comment. Now, what this led me down a little rabbit hole of was flashing back on some of my notes about the glorious relationship that the numbers 2 and 3 have. Now, this is a number that can be called 3 smooth. And the smoothness of a number is basically its largest size of prime factor. So like the number 28, its prime factorization is 2 squared times 7. It would be 7 smooth, but not 5 smooth. And so this number is 3 smooth, because although there's a bunch of 2's and 3's making it up, it's only those. There's no 5's or beyond in the prime factorization. And so 3 smooth numbers are super neat. They're, sort of like building block-like numbers. It turns out that there's only a limited amount of consecutive ones. The only ones that are consecutive 3 smooth numbers are 1, 2, 3, and 4. And by a smooth number, we're assuming that we mean a positive integer here. So 1, 2, 3, and 4 are all in a row as 3 smooth. They have no prime factors bigger than 3. And then the only other 2 in a row is 8 and 9 are the only other 3 smooth numbers that are neighbors. Now remember this, because we're going to come back to this in a minute. 8 and 9. So here already we get a fun thing about 3. It's sort of tucked between 2 and 2 squared as a blanket. So it's like sort of in its little bed of 2's. You got a 2 squared on that side and a normal 2 on that side. And so 3, surrounded by those 2's, and particularly in conjunction with that 2, has a lot of neat properties. Now, of course, 3 with that 2 squared is glorious too, because 3 squared plus 4 squared equals 5 squared has so many cool properties and is by far the most efficient Pythagorean triple. And so that's super cool, and we'll go into more detail over time. But today we're not looking at 3 and 4 as much, we're looking at 3 and 2. So the main thing that people know about 3 and 2's special relationship is that they're the only 2 neighboring primes. And to the comment, yes, smoothness actually is a technical term. So That is not in the category of my nicknames. That is a nickname that has become popularized. So, here, man, that train's really going. You get your roosters and your trains, but, you know, it's nice. A little soundtrack. So, 3 and 2, people mostly know that, okay, those are the only two neighboring primes. That makes sense because every future prime would be divisible by 2. Well, no, every future prime can't be divisible by 2, a prime bigger than 2. Otherwise, you know, it has multiple factors. And so every other number is divisible by 2. And so you'll never be able to have 2 in a row that don't contain an even. And so you're going to be stuck with that. 2 and 3 are the only neighboring primes, is pretty easy to prove. However, the one that people don't talk about as much that's super cool is, and this is one that did come up in a bonus video in the context of perfect powers, but it also holds true for traits about this smoothness here, is 2 to the 3, well, first let's look at something that came up in the sum product episode. In the last episode on the main channel, one of the things that came up is the identity 1 plus 2 plus 3 equals 1 times 2 times 3, ways that shows up, and ways it relates to the difference of sums and products of numbers. And in this case, it's basically saying that the difference of, since that times 1 does not change that product, it's basically saying that the difference of the product and the sum is 1 there. I didn't fully go into that part in the episode because it goes down other ways of analysis for bigger sizes allowed. But on this small size, we can break it down in that way and be like, okay, it's representing a case where the sum is 1 more than the product. Is 1 less than the product. And it turns out that those are the only 2 positive integers with a sum 1 less than their product, where both are positive integers, are 2 and 3. So we also get that cool identity. We get that their product is 1 more than their sum. And then the one that people don't talk about as much that's super cool is you take them to each other's powers, and those give you 8 and 9. Those only 2 neighboring 3 smooth numbers beyond this first cluster. And what else are 8 and 9? They are the only 2 perfect powers, assuming 0 isn't considered 1. A perfect power being a number a to the b, we're assuming a has to be at least 1 and b has to be at least 2. That the integer that results in, that can be expressed in that form, is a perfect power, like squares, cubes, and etc. And these are the only 2 neighboring perfect powers. And that's a really cool thing that was conjectured a long time ago and was only proven like 20 years ago or something. So I have the Wikipedia page of that here. Let's take a peek at that. So, here we can see that it was just proved in 2002 after more than 100 years of having been conjectured. And we see that there's a few ways of writing it, and one of them is that x to the a minus y to the b equals 1 is the only solution of natural numbers, is where x is 3, a is 2, y is 2, and b is 3, because we need to have them ordered for the bigger to smaller there to match. Now, what they don't really mention right away here, at least, I'm not sure if they mentioned this in the article or not, is that it's super neat that these are flips of each other. That the only case where this was true is 3 to the 2 minus 2 to the 3. Reminds me a lot of how these other cases that I'll show on a graph. So, time to look at graphs. So, one thing we saw the other day that's similar to this is x to the y minus y to the x equals 1. Now, This actually is similar, and let me make sure I'm a good size and then shrink this. So this actually is, no, wait. What we had here was equals 0. We had this before, and we noted that when x to the y minus y to the x equals 0, we know parts of this graph already. We know the 4, 2 and 2, 4 coordinates get passed through because the fact that 2 to the 4 and 4 to the 2 are equal is something that could be fulfilled as part of that. And so we see that solution and the other mirror of it there, where 4 to the 2 and 2 to the 4, or vice versa, have a difference of 0, meaning they're equal. But what if we change this fellow a bit? We put a slider on. Well, now if we're at 0, these things are touching, and they do, like I mentioned in the previous stream, cross the trivial solution you get here, which is when they're equal. If the numbers are equal, that works. And the crossing point of the trivial solution and the non-trivial ones is E. Isn't that cool? E. So, the irrational number E, about 2.7, that classic. So I consider very underrated. I can't really say it's better or worse than pi. They're such important numbers, both of them. But I can say that it's more underrated. So here, if we adjust this a little, and we're no longer looking at their difference being 0, but we're looking for cases where x to the y and y to the x are a minuscule amount apart, it's like that. Now, I could have gone vice versa and mirrored it this direction, but we're going to go this way, where we're saying we'll take x to be our larger number, and we'll say that the difference then will be positive here. That'll fit the case that I've set up later. And as we grow up to 1, here's the graph of when their difference of x to the y and y to the x is 1. Now, let's look at, it's not symmetrical because we need the order to matter here. X is the larger coordinate in this case. And so here, what's that? That looks a lot like a solution. And it's hard to know because some look like a lot like solutions, but that one is. There is a thing there at 3 for x and 2 for y. It passes through that grid point. And this conjecture can be phrased as saying that this graph doesn't pass any other integer points. Interesting, huh? So this is part of this type of equation called a Diophantine, maybe I'm pronouncing that wrong, equation. I've heard it pronounced different ways. But these Diophantine equations, or however you pronounce them, relate to integer or rational solutions to equations like this. Often the rational solutions can be derived from the integer ones because they can be scaled up or down. And in this case, they proved after 100 years there's only one solution, which they, didn't do just by looking at the graph, but we can pose the problem and solution in terms of the graph, that's the only grid point that got passed. So what about other cases? Well, here's if I say first of all, just for fun, this is if I flash them all on the screen with inequalities going crazy, but what really are those? Those are inequalities because it made the thumbnail look cool and because we might look at the inequality, but we're going back to equal signs for me to actually show you because that's going to be a lot more digestible of what's happening. So here we're looking at x minus y is 1. Here's the points where x is 1 more than y. And of course, this passes an infinite amount of grid points because there's an infinite amount of coordinate of, 2 numbers I could pick that are 1 apart, including them both being integers. But if I wonder, okay, x is 1 more than y, and that old thing was true, where x to the y minus y to the x, we're just going to turn that to a 1 for good now, is true, then look, I get a crossing point there. Now, interestingly, we can see a crossing point here, too. Now, what's going on there? Well, this is a... Okay, wait, no. So actually, we have to reformat our question a little, sorry. It's gonna pass this trivial point where one of them is 1. I forgot the restriction that we can't have our base be 1. Otherwise, it's way too easy to do, because we could pick things that... If we let them be 1, there's going to be an infinite amount of solutions. And so we would have to say that A and B are more than 1, X and Y are more than 0 is the sector of this graph that we would be looking at. So we would have to be looking at above the 1, 1 part of it. And that's right at the 1. So, sorry, I needed to clarify that. Beyond 1, 1, on all of the rest of the graph, this will be the only grid point we will hit. We do get a crossing at this more trivial solution where 2 to the 1 minus 1 to the 2 is 1. Now, here is actually just another phrasing of this one. So actually I'm going to get rid of it because I have it here too, in parentheses to match these. And here's the other thing I said that this number point should fulfill. We should see this crossing point get crossed again if I add that other trait about them that I said, that their product is 1 greater than their sum, which I can write as x times y minus the sum of them is 1. And yep, if I graph that one, it also hits right there. And the fact that these 3 all cross there is basically a visual demonstration of all that stuff I was saying, of 2 and 3 have this special trait where their product's 1 more than their sum, them to each other's powers is 1 apart, and they are 1 apart. And here's another one that happens to cross. Well, that's weirder. This is a completely different looking one. And this one is sort of a sneaky one that, to really make sense of this one, what we would have to do is add this x cubed and y cubed to each side so that they end up on that side. Call that a 1 cubed. Note that this would mean the sum of the first 3 cubes over here. Note that we can do a multiplied by 1 here without changing it. Note that that would make this the product of the first 3 numbers. And then note, the sum or product of the first 3 numbers, then squared, equals the sum of the first 3 cubes. And what are those numbers? This, 36. 100 if we counted in base 6. This number is 1 cubed plus 2 cubed plus 3 cubed. It's also either summing or multiplying the first 3 numbers, which gives you 6, and then squaring that result. Now, is that always true for things? Well, it does turn out that 100 is the sum of the first 4 cubes, as well as the sum of the first 4 numbers, then squared. But it's not the product of the first 4 numbers then squared. So part of that does hold true for many other numbers. This link between squaring triangular numbers, it could be called, as you'll see in future episodes. I'll go, well, yeah, let me think of how to say this. First, I'll finish this. Squaring triangular numbers does have an identity that connects it to sums of cubes. And that did show up in a short and will show up in a full episode later when I use actual animations that I'm working with someone on of animations of what are called polygonal numbers and polyhedral numbers. And the part that's only true for 36 is that you also could have taken the product of the first three numbers and then squared that. Because 6 being both the sum or product of the first three numbers gives it even extra traits that show up in cool ways to write stuff. This number, for example, could have many cool traits. I mean, this number was in base 6, if this was written, is this number as we know it, could have many cool traits. But we'll come back to this last identity that I just wanted to pop on there for fun later. Mostly these were three things that I explained a little more detailed about how these areas, or these different curves, and where they intersect or not, can tell us a lot about interesting types of numbers. So maybe you could play around on your own sometime, pick other numbers, and see something like, what interesting relationships can I find between the numbers 5 and 6 or something? Which did show up here as the product and the sum, so you could pick an even different example. And now I'm going to pause on these graphs for a moment after we color them to make them look cool. We'll say it's when they're less than or equal to 1. And you get some cool regions. And now I'm going to grow myself again to chat with the comments for a moment. Today we are not going to have a super long stream because I am going to be filming later today. So, I want to play a little activity with you folks right now, which is whoever happens to be here can help me decide what sort of interesting chaos should be incorporated into the beginning of the next episode. Now, there's sort of 2 next episodes, don't get confused. There's one that's coming out tomorrow, but then the next week's episode I'm going to start filming today with Carlo, my main camera guy. And that episode will be about language to a degree, but also about numbers. It's going to be about strange traits that emerge when looking at how you would write names of numbers, which might sound simple, but there's a whole rabbit hole to go down. And it will be just about English names of numbers. So if anybody speaks other languages, definitely leave a comment on that video of which of the patterns do or don't also apply in whatever other languages you know. I unfortunately just know English and like the barest shred of Spanish. And so this is just about English numbers, how the names are done. And in that episode, since last episode I filmed, that's coming out on the main channel tomorrow, doesn't have a crazy amount of chaos. A few clocks fall, but nothing too crazy happens. And it can be good in some episodes to have something catch the attention of the viewers, to trick people into sticking around for a deep dive into some math or science concept. And because I have fun filming those parts. So, a few ideas of what we could theoretically incorporate into the beginning of this next episode to make it quite catchy, which I will put letters next to so people can vote for them if they want. If anyone wants to vote, put it in parentheses the letter you want to vote for. And A is one that many people could predict. We could, of course, safely do a campfire. I'm going to write camp in front, but some sort of fire, maybe camp or other fire, is obviously one option. We could, of course, also incorporate, what was the other? I was going to say incorporate water, but those go kind of hand in hand, because when there's fire, the fire gets put out. So that sort of fire and water could be incorporated. We also could try and incorporate some of my cats. And we could try and stalk them down for the intro, and the intro could be me petting their belly somewhere. We also could incorporate large stack of clocks and stuff that is precariously set up so that at some point in my intro it wouldn't be too surprising if I bump it in a way that knocks it over. We also could, of course, what are some of the other classic combo class engagements? Well, of course, we can go for a more surreal sort of look with sort of our dice carpet, our clocks on the trees with eyes, and emphasize the strangeness of the combo classroom. And finally, well, I was going to put a bunch of dice, but those do not fit this episode topic quite as well as another one. So we could put like a bunch of books. We could put absurd stacks of books that I have indoors and see if those get knocked over. So to anybody who's around who wants to see any of these at the beginning of the next episode, before it ends up being, 15 minutes of me talking about numbers being spelled in English and surprisingly interesting traits that emerge, then leave a vote for which one of these you would like to see. And so, let's see. Let me go through the comments for a minute. Tree falling on me, we're going to skip that one. And somebody, it's hard to see this at all. This is having trouble. Now it's been easy to see for a minute. I'm always a little delayed because I'm seeing what you guys see, which is a little later. It takes a second to send. So, someone says they speak some languages. Yeah, you guys should definitely check out those videos and see which of them relate or don't. And maybe play your own games with some of the numbers. I'll give you a clue about one of the topics if anyone wants to investigate it in other languages in advance, is that, in fact, if anyone has any particular findings, they could let me know on the Discord or email or something if they make any particularly cool lists of what I'm about to mention. One of the topics in the episode is going to be what traits would emerge if you alphabetized an infinite list of numbers. If you tried to alphabetize all of the whole numbers going up from 1 or going up from 0, which actually changes some things. And if going up there, and I should leave these here. And yeah, if you were alphabetizing all of them, could you figure out, although the middle of the list would be infinitely long and clogged, could you figure out which numbers would be at the very beginning or very end of the list? Some languages may not have that trait in terms of their construction of larger numbers. But based on the most common and my favorite fully accepted way of categorizing larger numbers than we have a nickname for, where you attach a series of prefixes on, even with that series of prefixes and suffixes, there are ways to figure out the first and last number alphabetizing upward from 0. So if anyone I'll do that in English. I already, have that ready. But I even filmed a short of some of these things a long time ago that never ended up on YouTube, that I was worried would spoil the episode. But right when the episode comes out, I might put some shorts out about it too, because I already drew a chart of that in the past. And I'll do English, but if anyone does that in any other languages, that'll be cool. And I'll leave this up a minute just for people to take one more glance and see which one they want to go with, and then I'll look at what people selected. So what else is coming is that this is near the end of the grade, so the classroom's more trash than ever, but we're close to the reset. And after this next one that I'll be filming over the course of this week, the next episode that I'll be filming is sort of the last non-finale one, and is one I've promised for a while. Oh, I'm putting the wrong side of this up. One I've promised for a while, which is looking at infinite series of numbers to go into which ones diverge to infinity and which ones converge to interesting values. The funny thing about that is that one of my most popular shorts, not the most popular, but one of the most popular, did really well on here and on TikTok, is my one about the harmonic series, about how it diverges when you add 1/1 plus 1/2 plus 1/3 plus 1/4 plus 1/5, and that goes to infinity. And when you get a short that does well on one of those apps, you get a lot of comments of people who are not thinking very smartly or quickly. They're thinking too quickly or not smartly enough, or a mix. And so you got to be thick-skinned with those comments and be ready to not try and correct every wrong one, because there's going to be a lot of wrong ones. And it's one of those things, somewhat like what some call the Dunning-Kruger effect, where the people who are the least adept at math sometimes think they're the most adept. The people who are really good at math are usually pretty humble about, oh, I still have a lot to learn. And that, oh no, there's too much in math for me to know all of it. But people who know a little about math sometimes think they know all of it somehow. And so, which it's like, what? And so you get a lot of misconceptions on that video in particular, where when I say the video is basically me going, a lot of people don't believe me that the harmonic series diverges, so let me prove it. And so I prove it there. And I will redo that proof in a slightly more explanatory form in the full episode about reciprocal series, because a lot of the series we're going to cover in that episode can be considered as that harmonic series with some terms kept and some trimmed. A lot of them are part of that. And so there are two funny common misconceptions that come up on that infinite series video. One of which is a lot of people go, you're adding up an infinite amount of a thing. Of course it's going to go to infinity. And that misconception is funny, because I feel like people have been told in the past or encountered the thought that 1/2 plus 1/4 plus 1/8 plus 1/16 just approaches 1. It's basically just going halfway to somewhere. And that's an infinite amount of terms that doesn't go to infinity. 1/2 plus 1/4 plus 1/8 plus a 16th and so on. So either people just didn't encounter that yet, or they forgot it. But a lot of people were adamant in their comments that, like, of course it's going to go to infinity. There's an infinite amount of things. It's like, well, no, actually a lot don't, but the harmonic series does. And then you get the people who, tons of people in comments on there. I haven't even had the chance to read all the comments on the ones that are more than 1 million views, but I got the hint that there's like a lot of them with this vibe, which is, no, I don't believe it. That's not true. Like, that's not, they don't really just say that I don't believe it part, but that's really what's going on. They don't like the idea that this series that goes so slowly that it doesn't seem to approach infinity actually secretly turns out to approach infinity very slowly but steadily. And because it doesn't click with their intuitive reasoning, instead of trying to change their intuitive reasoning to meet it, they try and bring it to where their intuitive reasoning is at. So, warning to anyone when you're watching my episode coming up in advance. Yes, the harmonic series is kind of special in that, in some senses, it's one of, or the more minimal series that does approach infinity. One of the ones with a simpler definition that goes really slow but gets to infinity. There are, of course, ones that go even slower and get to infinity we'll go into. And then there are ones that look like they're going faster but then stall out. And so, like, what are the, if you take the reciprocals, 1 divided by each of these, what happens if you add up all the reciprocals of the factorials? What about all the triangular numbers? What about all the powers of 2? What about all of the primes? Well, some of those go to infinity, some of them don't, and the ones that don't go to interesting numbers, like certain integer or a certain constant you're familiar with. And the cool thing about that episode 2 is not only is it going to be the second last episode of the grade, and the last math one before the finale is more like documentary-ish, I'm going to let myself take as long as it takes. It might probably be 30 minutes. We'll see. Maybe it'll be shorter. Could be a 30-minute episode, maybe. but it'll be super cool. I'm going to have fun with it. And it's going to set up for a whole nother episode that's going to be its own episode in grade -2 about a $1 million question, literally, the Riemann hypothesis. One of these 7 questions that a particular math institute will award you a $1 million prize if you solve, although one of the 6 is already gone. But you could get $6 million if you crack all the other 6. But the Riemann hypothesis is the one I know the most about, and it's very interesting, and it does relate to infinite series of things being added up. So while that won't be the topic of the episode that we're starting with, at the end of the episode of Reciprocal Series, I will note that a few of the series we're looking at are actually particular values of this thing called the Riemann zeta function. And then I'll give a really quick hint about the question, which, to give you guys a question now, the amount of layers to unpack with the Riemann hypothesis, if you were trying to solve it, is each of these words is sort of a layer to unpack, but you're looking for all of what they call the non-trivial zeros of the analytic continuation of the Riemann zeta function on the complex plane, and seeing if all of the zeros that are known as non-trivial, because they're not on negative even integers, are on the line x equals 1/2 on the complex plane. And it's super trippy and interesting, and out of those $1 million problems, it's probably the easiest to explain, probably the only one that I'm ready to try explaining. So we'll go into that in grade -2. And I'm going to have too scattered of a lifespan's research to dedicate enough time to a singular problem to crack something like that. But maybe I will inspire some of you or give you some creative tools, and one of you will solve it. And all I ask is for you to use the word threeven in your acceptance speech. Let's see. It is 11 now. The stream is going to be an hour in a moment. And leave your last thoughts or comments. I'm going to go through the votes of what people voted for they want to see in the episode I'm about to film, because my main camera guy will be coming by shortly, and I'll be filming some interesting stuff. Stay tuned tomorrow for the one that's already filmed, that's in its late editing stages, which is about all those wacky bases and, like I mentioned earlier, cool traits that may seem obvious once you think of them, but more people should have sink in. So, let me check what votes people wanted for these. And we got B. Everyone wants cats. All right. We will be getting cats. Now, here's the thing. There are 3 cats with varying degrees of likelihood to get. There is Dandelion, the fluff monster, who you folks probably know the most. And he is very likely for me to be able to lure him somewhere and pet his belly during the middle of a take. Then there's Sage, who is a majestic, intelligent, loving creature. And if he's in a loving mood, he'll be magnificent in the take. And if he's not in a loving mood, he's going to go try and hunt some butterflies or whatever. Don't worry, I don't actually mean catching stuff. But then there's a third one, which is the stray that got adopted into the house and is now fixed and likes pets. And Sassafras is his name. He's less likely to be in the camera take. So I would say it's almost definite I can get Dandelion in the beginning of the episode, and medium chance I can get the other ones. I can show you a picture of how they do hang out. There's a small chance I can get all 3 of them. And was it this morning? Yeah. Either this morning or yesterday morning, I got a photo of them all chilling here. So, like, this is what I used to call it double trouble, when you get both of my cats in the same place. And now that rhymed, and we lost the rhyme but gained alliteration when we moved to Triple Trouble, which does have alliteration. So here is the three of them chilling. Oh, whoa, there's one. Sage, did you know I was talking about you? This is the one I said was so smart. Sage. Who's a good little Sage? Do you see Sage? He likes investigating. Come here, Sage. He's a good boy. He is such a nice angel. He just has to be in his right mood when he wants to be a love creature or solitary. So that's fun. What's under there? So you see him a little less than Dandelion, but he's so good. So both of them are going to get a big shout out with a lot of flashback footage shown in the finale. And as usual, when I'm editing for the finale and going through old flashback footage of stuff I want to show you guys about cats or clocks or whatever during the grade, a lot of that will be really briefly showed in the finale episode, and more longer, like a longer version of some extended stuff that's just more random or personal, will be showed on Patreon as well. So shout out to all my people on Patreon. There will also be a thank you to all of the Patreon supporters' names. Feel free to tell me if you want a different name there instead of what it says on there. Written on a whiteboard in the background of the episode that I will quickly be like, thank you to all these names, and make sure they're all in frame during the finale as well, because might as well thank all the people who are helping me transition out of having to be a private teacher and starting in March dedicate a lot more time to combo class, which, you know, we're still going to need a bigger budget to make work in the long run, but we're on a really good track considering this channel is less than half a year old and the other channel is less than a year old. Crazy, huh? So you can do a lot quickly when you work hard and you got crazy ideas, and sometimes you need a little help. I've gotten some help from my cats and from some friends and from some family and from the Patreon supporters, and to all the cool people who chat on the Discord. They are super cool as well, so make sure to check that out too. So thank you to everyone who joined me here. I'm gonna log off now. Later today there will be some sort of either a short or bonus video on here, because I'll film some other random stuff with Carlo as well. And tomorrow there will be a super cool episode about bases on the main channel. So thank you all for joining me. This was our very random special for the number that, if we were in base 6, wouldn't look like this, would look like 2 million. Now, if you want to have your brain think about some of this upcoming episode's topics in advance, look, the rooster's back. That's great. It was right at the beginning of the stream, and now it's going to wrap up the stream with us. So, this is the first time there's been a rooster here in a while. There was one a few years ago, but that was on the other side of the house. Hey, Sage, you want to say bye to them? Yeah, it's a good little Sage. Sage, come here. Sage. That's weird, isn't it, Sage? What's up with that rooster? Okay, so see you folks later. Hope you have a great day, and I'll catch you later in that short or bonus video or whatever.